Hello and welcome to Math 252. In this lesson, we are going to learn how to derive quadratic formula. I will show you step-by-step derivation of quadratic formula. Any equation that is expressed in the form of x squared plus bx plus c is equal to 0 is called a quadratic equation. Any mathematical equation that is expressed in this form is normally called a quadratic formula. So to derive a quadratic formula, we shall be using or make use of this basic quadratic equation. And then you also need to have a basic concept maybe on the how to use the completing square, and of course how to make a given expression a perfect square. Let's start. So to make to draw a quadratic formula from the equation we have, that is x squared plus bx plus c is equal to 0, we first of all take the constant term on the right side of the equation. Constant term here it is represented by the letter c. So we take c on the right hand side of the equation, and therefore our equation becomes x squared plus bx plus x squared plus bx is equal to minus c. So to use maybe, or on the left hand side we have the quadratic term and the linear term, and on the right hand side we have the constant term. So from here now we are supposed to use to make maybe the equation or the expression we have on the left hand side a perfect square. And to do so, we need to reduce the coefficient of x squared to 1. In this case, a is greater than 1, and therefore a is not equal to 1. And then we are supposed to reduce that one to 1, and we divide now a throughout the equation. We divide a on the first one, and then we remain with x squared. We divide a on the second expression, it becomes b over a, and also we divide c by a, and therefore our expression becomes x squared plus b over ax, which is equal to minus c over a. Having expressed the coefficient of x to 1, then we complete, or we make the expression we have on the left hand side a perfect square. To make a perfect square, we are supposed to add the coefficient of the linear term divided by 2 on both sides. That means we need to add b over a divided by 2 on both sides of the expression. We square it and then we add on both sides of the expression, and therefore b over a divided by 2 becomes b over 2a. We square it and then we add on both sides. B over a divided by 2 becomes b over 2a. Then that is the term that we are supposed to add on both sides to make the expression that we have on the left hand side a perfect square. We simply divide b over a divided by 2, and then it becomes b over 2a. We square it and then we add on both sides of the expression. Then from there, b over 2a square will always becomes b squared divided by 4a square. We expand now on the b over 2a squared on the right side. On the left side we leave the way it is, but on the right side where we have minus c over a plus b over 2a squared is where we are supposed to expand, and then expansion of this one therefore becomes b squared. We square the first one, that is b squared, then we square the denominator and it becomes 2 squared is 4, and then a squared becomes a squared. We rewrite again on the left hand side, that is x squared plus b over ax plus b over 2a squared, and therefore we add the expanded one on the right hand side, and it becomes negative c over a plus b squared over 4a squared. Then from there we factorize the expression we have on the left hand side. we simply pick the two terms that contain square, that is x squared and b over 2a squared. We give them a common square and place the two terms in a bracket, and therefore it becomes x plus b over 2 squared. That one is equal to, we again write on this side, we just find the LCM and then we express them into a common or maybe a single fraction. The LCM of a and 4a squared is 4a squared. 4a squared divided by a becomes 4a, then multiplied by negative c becomes minus 4ac, plus 4a squared divided by 4a is 1, and 1 times b becomes b squared. Then we take the square root of both sides. Square root of x plus b over 2a, and the square root of the expression we have on the right hand side. Then take the square root both sides, and it becomes square root of x plus b over 2a square is equal to square root of minus 4ac plus b squared over 4a squared. On the left hand side, the square and the square root will cancel each other, and we shall have x plus b over 2a. On the left hand side, on the right hand side, the expression we have, the top one, we cannot find the expression, that one we can't find the square root of the top one, but we can find the square root of the second one. We can manipulate the first one and we can start b squared plus rewriting the top one. It becomes b squared minus 4ac. Then that one we can't find the square root because that one does not have a perfect square, and therefore the square root of the denominator becomes 2a. Then we have x plus b over 2a is equal to plus or minus. Anything from a root now becomes plus or minus. We consider that both the positive and the negative signs is equal to b square root of b squared minus 4ac divided by 2a. The top one is just a manipulation or rewriting the expression starting now from the b squared. Then the next step is we take b over 2a from the left expression on to the right side of the expression. It becomes x alone on this side is equal to minus b over 2a plus or minus square root of b squared minus 4ac divided by 2a. And then finally we rewrite again, or we make this expression on the right hand side to be a single fraction, and the LCM of 2a and 2a is 2a. So 2a divided by 2a is 1. 1 times negative b becomes minus b, plus or minus 2a divided by 2 again is 1. 1 times the expression on the top remains the way it is, and therefore x becomes minus b plus or minus square root of b squared minus 4ac divided by 2a. This is called quadratic formula, and this is how it can be derived. Therefore, anywhere maybe that you have the quadratic equation and then you're told to solve, you are free to use this quadratic formula. Now a in the expression represents the coefficient of x squared, b represents the coefficient of x, and c represents the constant term. Thank you for watching, and then maybe we'll come back and do maybe questions using this quadratic formula. Thank you for your time.